Okay, there we go. Okay, so section 5.1. We are starting into like more about what a derivative does and like what it means and stuff. Okay, so we know derivative to mean three things right now, right? Okay, a derivative. Okay, it is going to be a lot of algebra, yes. So a derivative. First and foremost, we talked about a derivative being a slope of a tangent line, right? Tangent line. We're going to talk about more about that today. So this is the one that we're focusing on today, it being the slope of a tangent line. We also know that the derivative is velocity. Second derivative would be acceleration, but I'll just write velocity for this one. And then also rate of change. You do derivative to find rate of change. So like the rate that the radius is changing with respect to time. All of those things are used to represent derivatives. So it's hard to imagine a world before we knew what a derivative was, right? Like, because it's so useful. It's just awesome, right? What did I do without? What did we do without you, right? Okay. So, when we're talking about maximums and minimums, I'm going to skip this definition. Maybe we'll come back up to it here for just a second, but I'm going to show you how this works. And we've already talked about this before, okay? When we're talking about derivatives, derivative is a slope of a tangent line, okay? The important part that we're getting to is like this minimum point right here, like the minimum on a graph, right? If I draw a tangent line to him, that minimum, at that exact point, his tangent line will be horizontal, right? Okay, what will the slope of this guy be? 0, okay? His derivative will be 0 at that point, okay? So here is why this is so important. If we have an equation, let's say like a quadratic function, quadratic function to represent expenses for our business, and we're trying to find the minimum expenses, like when the minimum occurs, how many things we have to produce in order to minimize our expenses on our production line. What we're going to do is this quadratic function that represents our expenses over time, we can take the derivative and set it equal to 0, and that will give me the lowest point on my graph where the expenses are at a minimum. Does that make sense? Okay. In addition to that, we can do the same thing with like maximum points. Okay, if I have something that's curvy, like a quadratic function, or it could be a cubic function, maybe it goes down and back up again, whatever, and we have a high point, this guy is going to have a horizontal tangent line as well, where his derivative, the slope of that, is 0. Okay. If we are trying to, let's say, maximize profit, and this is what our profit curve looks like, we would take that equation for profit, find the derivative of it, set it equal to 0, and that would give me my high point. Does that make sense? Okay. Does that make sense at all? Okay. Those zeros occur at high points and low points. Now, the problem is, let's say I have a curve. I'm going to go down here one more. Let's say I have a curve that's doing one of those, right? Like a cubic function that's doing one of those. I am going to get 0 as a tangent line, or 0 as my derivative here and here. So then I have to do a few things that distinguish between whether that's a maximum or a minimum, right? Does that make sense? Okay. Now, we're assuming that we don't know what the graph looks like, right? So I'm going to get two answers there where my derivative is 0, and I have to make sure that I pick the right one. So if I'm trying to maximize profits, I want to make sure I do this one, minimize the other one, right? Just guess, right? Okay. So that's what we're going toward, okay? So the definition of derivative, up here at the top, we're going to start talking about extrema is what they call them, and extrema is just the plural of extreme values, which are maxes and mins. Okay, so when it asks for extrema, it's just saying find where the maximum is and minimums are located, right? Okay, so the minimum and maximum of a function on the interval are the extreme values, or extrema. The singular form of extrema is extremum. Of the function on the interval, the minimum and maximum of the function on an interval are also called the absolute minimum and the absolute maximum. Okay, if you have more than one, or you have like higher or lower places, a lot of times they'll call it a relative minimum. Okay, so looking here on this guy, this one that I just drew down here, This guy is a maximum, but he is not an absolute maximum, because on the right side of that graph, he does go higher than this point. Does that make sense? So he would be called a relative maximum, okay? This guy is called a relative minimum, all right? Does that make sense? Because in relationship to everything else around him, yes, he is the lowest point, but these points that are down over here are going to be lower than he is. So he is not absolutely the lowest point, okay? This one that I drew, this is a quadratic function. Since he's going down on either side and never going back up again, this guy would be an absolute max. Does that make sense? Yeah, an absolute highest point on the graph? No. Where are you going? Okay, whatever. So absolute maximum. All right, so that's kind of what they're talking about here. They talk about maximums and minimums. When you have a graph that is stopping, like if I'm only looking at this interval right here, where he's not continuing going up forever, we will consider the end points to be maximums, right? So this is a maximum, this is also a maximum, unless you have open circles. If it's an open circle, meaning we're not evaluating there, it's obviously not a maximum because there's no point that exists there, right? Okay. So they will take a graph and sometimes they'll lump it off. Like, let's say we do have an equation that's representing time or something. Well, time can't be negative, so they kind of cut it off at that time, right? So we would have a definite left side of my function, and if that's a closed circle, they will call that a maximum point. If it's an open circle, they'll call that not a maximum because it's not evaluated. Okay? Let's see, this guy's not a minimum because he's an open circle, but this one is a maximum because he's a closed circle. Okay, so also take into consideration when you're doing this the end points, because you know that's where he's cut off at. That's where his highest point is. Okay. All right. Theorem 5.1 says that if f is continuous, then he will have a definite maximum and minimum on the interval, even if he is, like, let's say, a linear function. On a closed interval, let's say I'm only looking at this section from here to here, even if he is a linear function, this would be considered my max, and this would be considered my min, okay? If he has curvy parts, he will always have a maximum and minimum, is what that's saying, as long as I have a closed interval, right, where we're only looking at this chunk of graph and assuming that he does not go on forever on the outside of that, right? That just kind of is like a basic thing. All right, so this is what I was talking about down here, relative extrema and critical numbers. This guy is a maximum point, and he will have a derivative or slope that's equal to 0. Same thing with this guy. He will have a derivative or a slope that's equal to 0, because those are maximum and minimum points. Their tangent line is horizontal, so 0. Okay? Find the value of the derivative of each at the relative blah, blah, blah. Okay, so they give us the graph on number 1. They will not on your homework assignment, but just to validate like how this works, I went ahead and put the graph on there. So if we take the derivative of this guy, he will be, what, like 3x squared minus 3? Okay? If we want to find the high and low points, these two guys right here, assuming we don't already know where they're located, because you can see it on the graph where they are, we would set this thing equal to 0. To find the high and low points, we set them equal to 0. Okay? And then just solve for x. So I would add 3 to the other side. 3x squared equals 3, and then divide by 3. So you have x squared equals 1, right? And then I take the square root. And what is the square root of 1? Plus minus 1, right? So I know that I'm going to have a high or a low point at 1 and negative 1, right? And you can see that from the graph. I have a low point at negative 1 and a high point at positive 1, right? No, the other way around. At negative 1 on the x right here. Negative 1, comma 2, that's a high point, and positive 1, comma negative 2, that's a low point. So, at 1 and negative 1, you're going to have high and low points. Okay? So, for right now, they're just going to ask you for probably maxes and mins, and they're not going to say which one it is. They're just going to say find the relative extrema. You take the derivative and set it equal to 0. and you know that 1 and -1 is either a maximum or a minimum, but we don't necessarily know which one right now, right? In section 5.2, we're going to do some more tests on it to see which one's which. Okay? All right, find the relative extrema here. All right, now, this guy is an absolute value function, and the problem with absolute value functions is this derivative, or this guy right here, I talked about this last chapter, I think, maybe, like at the beginning of chapter 4, right before Christmas break, and I didn't do a very good job of explaining this. So if I try to draw a derivative to this line, like where he's only going to touch at one point, I can draw it horizontally, or like if I slant him just a little bit, he's still only going to touch at one point because he is not curvy. He is like coming to a tip, right? This guy, if I slant him this way, he would come to a tip. You know, there would be an infinite number of lines that's only going to touch him at one point because he comes to a tip and not a curve, okay? So when we're finding the derivative at each one of these points, this one is not going to have a derivative because he comes to like a straight corner, right? So he has to be curvy in order for you to find the derivative. You can find the derivative of the absolute value of x, but then when you go to plug numbers in and stuff, it like fails because you end up with like a 0 in the denominator, and we'll see that on the back side of the sheet. So this one, we'll say the derivative, derivative does not exist at, we'll say at this point, at the bottom point, okay? You can still take the derivative of that function. I'll show you how here on the back side. You can still take the derivative of that function only for all of the other points along the curve, right? So like for these points that live on this line, these points that live on this line, that's why we are still allowed to take the derivative, but when we plug numbers in for this exact point here, it's going to fail. I'll show you how that works in a second. So if it comes to a straight corner, the derivative is not going to work at that point. Same thing if he like has a hole or a vertical asymptote, you're not going to be able to take the derivative at that point. Okay? All right, let's go back. Definition of a critical number. Critical numbers are where the derivative equals 0. Okay? So places where the derivative equals 0 are the maxes and the mins. Or they say at, and I'm going to put this in all caps, or at end points. So if they say find the critical numbers for this equation, the first thing that you're going to do is you're going to take the derivative and set it equal to 0, because those will cover all of your maxes and mins that you'll have along that curve. And also your critical numbers will also include any endpoints that you have. So that says we're only looking at this interval from, example, if we're only looking at the interval from like 0 to 2, 0 is a critical number and 2 is a critical number. Both critical numbers. In addition to any other maxes and mins that live in between 0 and 2. Does that make sense? Maybe? Okay, so not only are you going to set the derivative equal to 0, but you're also going to look at any endpoints. If they say you're only looking at this interval, 0 and 2 will also be critical points. Note, this includes the endpoints of an interval because the derivative cannot be found there. We have to also look at those endpoints, okay? All right, relative extrema only occur at critical numbers. Okay, this is just saying that if I take a function and I set it equal to 0, that is going to cover all of my maxes and mins, or all of my critical numbers. Relative extrema. So it's going to cover all my maxes and mins. You will not have any maximums and mins that don't occur at 0, that aren't where your derivative is equal to 0. A maximum and a minimum has to occur when your derivative is equal to 0. Okay, so you don't have to do any funky business after that. As soon as you set your derivative equal to 0, you have found all of the possible maximums and minimums that there are. Okay. All right, so here we go. This is what the function looks like, and they will, blah, blah, blah. They won't give you that graph. Find the extrema, okay, of this function on this interval, okay? So we have critical numbers, and we know from this table that there will be 4 critical numbers, okay? There are 2 places where the derivative is going to be equal to 0. And then I have my left and right endpoint. My left endpoint is going to be the point -1, and my right endpoint is going to be the point 2. Okay, because they tell me I'm only looking at this chunk right here. Okay, there are 2 other critical numbers in between those 2, giving us a total of 4. They will not tell you how many there are, but there will always be 2 for the right and left endpoint, and then maybe a couple in the middle. Okay, so to find the couple in the middle, we take the derivative and set it equal to 0. Okay, all right, so help me with the derivative. Let's see what that guy is. What do you got? 12x cubed minus 12x squared. We're going to set that equal to 0, because by setting it equal to 0, we're finding the horizontal tangent lines where the maximum ends up. Okay? So, now I want to solve for x. What can you do? Yeah, take out an x squared. Really, you could take out 12x squared if you wanted to, right? And left over would be like, I don't know, x minus 1, right? Okay, so if I set both pieces equal to 0, if I set 12x squared equal to 0, I would divide by 12. So x squared is still 0. And I take the square root. Am I going too fast? X equals 0 is one of my critical numbers, right? Well, yeah, it really is plus or minus 0. It really is plus or minus 0. That's exactly what it is, but whatever. So one of my critical numbers is 0. The other one is, when I said x minus 1 equal to 0, so x equals 1. Okay, try to put them in order from left to right if you can. Like, that would be ideal. Don't put 1 here and 0 there. So my critical numbers in between are going to be 0 and 1. Okay? Good? Yes? Beautiful. Find the extrema on the blah, 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 blah. Okay, let's do this. I told you before we weren't going to determine which ones were going to be maxes and mins, but let's just go ahead and do it. So this might be telling you more than you needed to know. These are the places where my extrema are going to be, and those are just specifically the x coordinates. So x is -1, x is 0, x is 1, x is 2. But can I find the y coordinate that goes with that? And how would I do that? Plug it in where? In the original, right? I'm going to plug that into the original to give me where that point is going to be located, right? Okay? So, if I plug -1 into the original, this is like 3 times -1 to the 4th minus 4 times -1 to the 3rd. Okay? -1 to the 4th is going to become +1, so this is just 3. And that's going to stay negative, so 3 plus 4 is 7. Right? And you can see from the graph, it is at -1, 7. Right? Beautiful, beautiful. If you plug 0 in, what do you get? 0, 0, right? Okay. All right, now, if I plug 1 in, I would get like -1. If you plug 2 in, I'm going to cheat from the graph. 2 corresponds to 16. Okay, so those are the points where my critical numbers are going to be. This is an endpoint, that's an endpoint, these 2 things in the middle, something maybe is happening there. Now, which one is a max and which one is min? Whichever y coordinate is lowest, right? 7, 0, -1, 16, which is the lowest. This one's going to be my minimum point, the lowest point on my graph, according to that interval, right? This is going to be my minimum, which is the highest point along that graph. 16. Can you have 2 minimums or 2 maximums? Like, let's say this left side came all the way up to 16, and I had 2 16s. Would they both be a max? Yes. You would list them both as max. You can have 2 if they're dead even with each other. Make sense? Okay? All right. Okay. All right, last one. This is how you find the derivative of an absolute value function. Okay? All right. So the derivative of an absolute value function, I can write a rule over here. So if my absolute value, let's say the absolute value of u, okay, this is the rule for the derivative of the absolute value. If I'm taking the absolute value of u, you will take u prime, whatever that is, outside of the absolute value, u prime. That means the derivative of the inside. U prime means the derivative of the inside. Okay? And I will multiply that guy by u over the absolute value of u. Okay? So the other two guys stay the same, except we'll put him on the bottom. The absolute value will go on the bottom. That same thing outside of absolute value will go on the top, and then the derivative of that will go on the outside. That's the derivative of an absolute value. So that's what they've done here. This guy, 1 minus x squared, is over 10 times the derivative of that whole thing goes on the bottom. I take it out of absolute values and put it on the top, and then the derivative of 1 minus x squared is just negative 2x, and gets multiplied out in front. Okay? All right, find the extrema. I'm gonna do a table like I did up above. Okay, table like up above, except I don't know how many. I know I'm at least gonna have an end point. So I'm gonna have an end here, and I'm gonna have an end here. And my endpoints are gonna be at -2 comma something and +2 comma something. You see how that works? I put a big chunk in the middle because I don't know how many critical points I'm gonna have in the middle. Okay, I don't know exactly how many there's gonna be. All right. So how do I figure out what the ones that are gonna be in the middle here are? Equal what? What? Yeah, I set the derivative. They've already given me the derivative of this guy because they were nice. I'm going to set that derivative equal to 0.
I thought you said like
for an absolute value? So the bottom is just the absolute value of u. So it stays the same as what it was. It pops out of the absolute value, that's your top. This thing is your u prime. So the only time you use a derivative when you're taking a derivative is that number that goes out in front. Okay, so this is how you get it. All right, if I set it equal to 0, then the really nice thing is this bottom part, if I try to multiply him to the other side, it's basically going to go away, right? So I have that going on. You guys see how that goes away? If I multiply him to the other side, multiplying him by 0 is going to make him go away. So now I have these two pieces, and I can just basically individually set them equal to 0, right? Okay? So if I set -2x equal to 0, and if I set 1 minus x squared equal to 0, I'll get my two sets basically of critical numbers. So if -2x equals 0 divided by -2, and x is 0, so that gives me one critical number. And what do you want to do to this guy? You subtract the 1 or add the x squared? What? Add the x squared, okay? 1 equals x squared. If I add the x squared to the other side, then I only have to deal with positives, right? And I'm taking the square root of 1. So how many critical numbers are you going to have total in the middle? 3 of them. You're going to have 3 of them. So plus minus 1. So I will have 3 of them. So my critical numbers in the middle will be, there's my critical numbers, critical number, critical number, critical number, okay? Will be, if I go in order, -1, 0, and 1. Okay? So even though the derivative cannot be found, if you see those two little tippy points down there, even though the derivative can't really be found at those points, I can still use them to find my critical numbers and find how high and low they are. Right? So if I plug those into the original function, like -2, if I plug him into the original function, that'll be like -2 comma, I'm going to cheat, -2 comma 3. Okay? The other endpoint will be at +2 comma 3. Yeah? -1 and +1 will both be at zeros. And if I plug 0 into the original function, I get 1, right? Okay, so maxes and mins, we'll see where they're located. Where will my maxes be? At what? -2, 3, and +2, 3. Here's my max, and here's my max. You can see that from the graph, but you can also tell from the table those are the highest y's, yeah? Okay, where are my mins located? That's my lowest points. At the zeros, right? At these guys. So this is going to be a min, this is going to be a min. Right? Make sense? Ish? Kind of? Okay, there you go.
I look at my water and then see my list. full. So
Sure.
are you sure it wasn't a navy blue water bottle?